is Olivia over at Prepaze, and today we'll be going over our fourth episode in our function series. Today in particular, we will be going over other additional definitions that we can add via the function of our graph. So in our second video, we talked about the vertical line test being able to be drawn and dragged over the graph of our function to confirm whether it is a function or not. Now today, we'll learn a little bit about defining a function in a more descriptive sense, and that is defining at what points is it increasing or decreasing. Now for this example, I'm going to pull up my skateboarder guy that I've so eloquently drawn here, and I want you to imagine that you're riding a skateboard, and the skateboard is traveling, you and the skateboard are traveling along the top of your function, the graph of your function. So notice if I started up here, this was the start of my line, and I start going down and down and down, this is probably a pretty dangerous skate park, all the way up until x, or my horizontal distance is 0, I will be traveling down. We would consider this decreasing, reading left to right like a book. However, once I hit 0, I'll end up rotating and traveling up in the other direction. I've drawn another guy here for the assist. So starting at the vertical distance of 0 and then increasing in the positive direction, we're going to be skating uphill if we're looking from left to right. So depending on whether you on your skateboard travel downhill or uphill on the function is how we define at what point is our equation in our function increasing and decreasing. Let's look at this a little more closely. Now, one of the cool things about the function y equals x squared that's a little bit hard to display is that it actually continues infinitely in the positive and the negative directions. So think about this. If I plug in the value of negative 10 as my input, negative 10 squared will be 10 times 10, 100. But doesn't mean I can't plug in an even bigger value in the negative direction. Negative 20. Negative 20 squared, 400. Negative 30 squared, 900. It will continue infinitely in the negative direction. In the same way, in the positive direction. So it's a little bit hard to display infinitely expanding and continuous functions in a graph. So typically, we have our little cut, and then we use these arrows to show how it extends. So if we talk about at what point does our skateboarder start to skate, that's going to be at negative infinity. This graph is continuing, increasing, increasing, increasing up towards the negative direction. So from negative infinity all the way down to the point where we change directions and start going uphill, that's at x equals 0. So we can say our equation is increasing. We're going downhill, decreasing from negative infinity to 0. And this is based off of the domain definition, or the range of our x values. Another way to write that our function, y, is decreasing from x being in between negative infinity. We can't be equal to negative infinity because it's infinity, and 0. Then we can do the same thing for increasing. We're increasing from 0 all the way. Our hill doesn't stop because our function continues infinitely. So y, our function, is increasing on the domain 0 to positive infinity. And there are a couple ways that we can write this, but for now, let's do our inequalities. X ranges from the values of negative infinity to 0, that's when our skateboard's going down, and from 0 to positive infinity, our skateboarder is going uphill. All right, great talking with you. I'll see you in the next video.